Okay, welcome ladies and gentlemen, and what we're looking at today is going to be present value. So we're on our last unit and we're looking at present value. This will be your homework at the end of this lesson, and certainly you can use your textbook and read over the key concepts and figure out what's going on from there as well. So I'm going to go to our lesson that we have, and present value. So present value, often people will invest money. They have a goal for which they have a specific amount of money that they want at a future date. The principal that's invested is called the present value of the investment. The present value that will result in a specific amount with accumulated interest then can be calculated by rearranging the term in the compound interest formula. So your compound interest formula, just to give you an idea of what's going on here, is A equals P1 plus I to the n. So this is our compound interest formula. That gives you your interest, your compounding periods, your principal, yada, yada, yada. Well, if I want to have a certain amount of money, let's say it's A that I actually know, and I want to rearrange to find P, well, what we're going to do is divide both sides by 1 plus I to the n. And I got to divide both sides if I'm going to keep the inequality, which gives me the principal that would be needed to have this amount of money at the end of a certain amount of time is given by this formula. Now the only thing we do is, since it's called present value, we use P dot V equals A over 1 plus I to the n. And that's the only difference there, is that we're using P dot V rather than just P for principal. So there's your formula. You can memorize it if you want, or you can understand how to get it by rearranging. You know which one I'm going to choose. I'm going to rearrange it. So I'm looking at our first example here, and we have Tom. Tom would like to have $10,000 in an account in 9 years. So how much should he invest now? That's the tip-off. How much should he invest now at an interest rate of 5.75% per annum per year, compounded semi-annually? So the formula that we're going to use is present value equals the amount over 1 plus I to the n. The amount that he wants is $10,000. The I is the effective interest rate, so it's going to be 5.75% divided by compounded semi-annually, twice a year. You got to change that. You got to change that to a decimal, so it's going to be 5.75 divided by 100. So then we're going to divide that by 2. And it gives us 0.02875. Now, n is the number of compounding periods for the life of the loan. So it's twice a year times 9 years is 18 times. We have all the information that we need. The present value that he needs to invest now will be 10,000 over top of 1.02875 to the 18. Now remember, that's just a 1, so that's where that 1 came from. So using your calculator, and you're going to have to figure out how to do this, but I'm going to do 1.02875 to the exponent 18. I'm going to have that number, and I'm going to divide that by 10,000. And you know that that's the actual opposite of what I wanted. So I'm going to find my button that does the reciprocal, and that's going to give me an answer of $6,003.75 and a little bit. So if I don't have that little bit, I'm not going to really have $10,000. So I better put in an extra penny, so I'm sure that I'm going to have my full amount of money when the time comes. So I need to invest $6,003.76 now if I'm going to get a rate of interest of 5.75 per annum, compounded semi-annually for 9 years, to have $10,000. That's it. The school band is planning a fundraising event to help finance a trip to England in 3 years. So they want to go to England in 3 years. The band plans to invest money for the event for 36 months. Well, 36 months and years aren't matching up. So 36 months divided by 12 is going to be, this is actually 3 years. So there you go, that's a good thing. So they're going to be investing money for 36 months, which is 3 years, which is when they want to go. Well, that makes sense. And it's going to go into an account that's going to have a return per year of 4.5% compounded monthly. The band hopes the money from the investment will provide $8,000 towards the cost of the trip. How much does the band need to raise and invest to achieve this goal? So how much do they need to invest now into this scenario so that they'll have $8,000? So present value is going to be amount over 1 plus I to the n. The amount that they're going to want to have is $8,000. The I that they want is going to be 4.5% compounded monthly divided by 12. So 4.5 divided by 100, that gets rid of the percent, divided by 12, gives us a pretty small number, and it looks like I'm in scientific notation, so I'm going to change that, and I'm going to go to, I want to be in normal, so mode 9, there I go. So it's going to be 0.00375, and n is going to be how long is it invested for? 36 months. So that's going to be number of years, 3 times 12 months. Well, it's the same thing, right? So it's going to be 12 times 3, or they gave it to us in the question, 36 months. So let's see, it's going to be 8,000 over top of 1.00375, 36. So how am I going to do this? Well, I could do this differently. I could start off with the 8,000, divide it by 1.00375 to the exponent 36 equals, and I'm getting my answer of, they need to invest now, 6,991.49238. So I need to invest a little bit more, less than a penny to make sure that I have the full amount. If I don't invest this little bit less than a penny, then I'm not going to have the full amount, so I better put in $6,991.50. Now let me just check that that works. So if I went about it and did it the other way, 1.00375, the exponent 36 equals, divided by 8,000, 1 over the inverse, and it works. Okay, not inverse, sorry, reciprocal. Okay, so B, how much interest would the band earn? How much interest should the band earn to meet this goal? Well, if this is what they're depositing now, and if they want 8,000 in 3 years, then the difference must be the interest. So the interest must be the amount that they deposit, or the amount that they want, and the amount that they deposit. So 8,000, take away 6,991.5, and we get they're going to earn about $1,000, $1,008.50 in interest. And I think that's it for present value. After that, we start talking about annuities, which is kind of neat because that's the basis of mortgages. Okay, ladies and gentlemen, that's it for me.